What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 12, Section 3, the Parabola. Let's do it. So we're defining a parabola in terms of its focus and directrix. Let me draw each one out and show you exactly how it relates to the parabola. So we're going to call this the focus of a parabola, and this is going to be the directrix, right? It's like a line like this. The parabola is going to come around like this. And the way we define the parabola is as follows. And obviously this isn't perfectly drawn, but the distance from the focus to any point on the parabola is equal to that point on the parabola and the distance coming straight down perpendicular with the directrix. Another example would be up here and then coming straight down here. So again, I didn't draw it perfectly, but those distances should all be the same. So the parabola is therefore the set of all points that have that relationship between the focus and the directrix. Done. If the equation of a parabola is written in standard form and P is negative and the directrix is a horizontal line, then what can we conclude about its graph? So if the directrix is a horizontal line like this and P is negative, what that means is my leading coefficient for the x squared is going to be negative, right? Something like that. And then what that means is, okay, directrix going this way is either going to go up or down, but because we have that leading negative coefficient, it's going down like this. So the parabola opens down, done. As the graph of a parabola becomes wider, what will happen to the distance between the focus and the directrix? So what's going to happen is as this gets wider, the distance between these two is going to increase. I'm going to show you an example in Desmos. All right, so what I did is I created a parabola, and what you can see here is there's the focus and there's the directrix, okay? So what we can now play around with is we can see what's going to happen as this gets wider, and where does the directrix and the focus, where do they go relative to each other? So as you can see here, now as I increase this p-value, I made it much wider. It's hard to tell, but we've sort of increased the scaling here, and the distance between the foci and the directrix just kind of keeps on increasing. So it increases, and that is how you do it. Done. So this one is definitely a parabola. We have one variable squared, the other one is not, and so that's definitely legit. Now, the way that they want us to put this in standard form is to isolate that x squared value, right? So we're going to say x squared is equal to 1/4 y. Now, just recognizing that this should be our standard equation, right? But also saying that h and k would be the vertex of this parabola. This one over here has a vertex of 0, 0, right? So we don't have to worry about the h and the k values, but since on the right-hand side, it should basically be 4py squared, and we have this, I'm going to rewrite it with a 4 out front. Well, if I extract a 4 out of that 1/4, meaning divided by 1/4, what do I have left? Is I have 1/16 times y, which means this is my p-value. But anyways, that's how you do it. Done. For number 9, yes, this is definitely a parabola. Again, just the y term is squared, not the x, so this is pretty much good to go. And it's almost in standard form. The only thing I want to do is, because the standard form we're given that we're applying here, we need to have a 4 in front. So if I pull a 4 out of the 8, what do I have left? I have a 2. And this would be the standard form. Again, 2 would be our p. That's how you do it. Done. So to put this one in standard form, first I'm going to isolate the y squared. So it's y squared is equal to 1/8 x, okay? And then we know that we need this to be in that 4p situation, right? So we got a 4, we're going to extract the 4. It's like I'm dividing that by 4 or multiplying it by 1/4. So that becomes 1/32 times x. So this is now my p-value. So that's pretty important. Okay, so now if we want to figure out the vertex, so again, it should be x minus h, y minus k. Those will be our vertex values, but there's nothing there. So my vertex is going to be at 0, 0, okay, right at the origin. Now we can get the focus on the directrix. And by the way, is this going up, down, or is this going left, right? Well, since the y is being squared, it's actually going left, right. And because this is positive, it's going to be opening to the right, okay? So I like to have a little graph like this just to remember that the focus is going to be inside, the directrix is going to be outside, sort of like this little platform that this parabola is hovering on top of, right? And what is that? That is a vertical line. So I already know from my directrix, I need a vertical line, which is x equals something. And then to get that value, we have to look at our p-value and say, oh, we went backwards that amount, whatever that p-value is. And the p-value we said is 1/32, which means the directrix is x equals -1 over 32. And then what about the focus? Well, the focus goes in the other direction, that same p-value, right? So the focus, we're still staying on that y value of 0. That's not changing. But then the x value, it's going up by 1 over 32. So that is how you do it. Done. So for this one, first, we're going to isolate that x squared. So I'm going to divide both sides by -4, which is going to be -1/4 times y. So again, we know the vertex, since there's no x minus or y minus or anything like that, we know the vertex is at 0, 0, the origin. And then now to get it into that nice standard form, remember, we want a 4 in front, ideally, right? So I'm going to pull out a 4, and it's like dividing this one by 4, which makes it -1/16 y. And now we have our p-value, okay? And by the way, since it's x squared, it's either going up or going down. Since that's negative, it is going to be going down. So it's nice to just kind of have that rough idea in our mind. Now, using that p-value, I can get both the directrix and I can get the focus. So again, the focus is going to be here. The directrix is going to be a horizontal line like this. And the thing about that p-value is the directrix is going to be that p-value up in this case, because it's going down. So it's going the other way that it's opening. So -1/16 added onto that y value is going to be y equals -1/16. That's my directrix. And then the focus goes the other way. Again, we're keeping that 0 for the x value, but then we're moving. So since it's above, we're adding +1/16 for the directrix, right? So it's y equals +1/16. And then for the focus, we're coming down lower. So we're now adding that -1/16 to that, and it's at 0, keeping the x value the same because it's directly below the vertex, and then -1/16. That's how you do it. Done. So for this one, we're going to start by dividing both sides by 1 over 36. So it's y squared equals 1 over 36x. And just to get it a little bit more clarified, we're going to pull out a 4 from that, meaning divide 36 or 1 over 36 by 4. So I'm going to pull out a 4, and that's like multiplying that denominator by 4. So it's 1 over 144x. Okay, so since it's y squared, this is going to be going left to right, but since that p-value is positive, it's going to be going like this to the right. Okay, that means the focus is going to be here, the vertex here, and our directrix is going to be a vertical line like this. All right, so first of all, what's the vertex? Well, the vertex, since I have no x minus, no y minus, my vertex is the origin, 0, 0. And then my focus is this point in here. It's going to the right by how much? By that p-value of 1 over 144. So my focus is going to be 1 over 144 comma 0, right? Keep that y value the same. And then my directrix is this vertical line coming that p-value distance back. So it's going to be directrix is x equals -1 over 144. That's how you do it. Done. So for this one, we already got it in our perfect standard form, and we can see our vertex is the opposite of both those values in the parentheses, right? It's just 1 comma 1. And since we already have a 4 extracted, my p-value I know is an invisible 1 there, okay? So since my p-value is 1, and this is x squared, and it's a positive p-value, I know that this is going up, okay? So that means the focus is above, the directrix is below. So to get my focus, I'm going to add that p-value to the y value because, again, it's straight above the vertex. So the focus is 1 comma 2, and the directrix is a horizontal line 1 below that vertex. So that's going to be at 0. So my directrix is y equals 0. That's how you do it. Done. So for this one, we pretty much got it in standard form. The only thing I'm going to do so we can see our p-value a little bit more clearly is I'm going to pull out a 4 from the 2, right? So it's basically like I'm dividing this by 4, which turns that into a 1/2, okay? And then now we can see the p-value is that positive 1/2. And we also see that it's a y squared, meaning, and a positive p-value, meaning it's opening to the right. I always like to draw that out. That means the focus will be in here. Here's the vertex, and our directrix is going to be a nice vertical line like that. All right, let's get the vertex first. The vertex is going to be the opposite of these two values, so -3 for the x, +4 for the y. Then my focus, since I know it's to the right, and by how much? By 1/2. So I'm going to add 1/2 to the -3, and we get 2.5, or we can say negative 5 over 2, comma 4. There's the focus, right? The y value stays the same, lined up with the vertex. And then the directrix, we go that value backwards, right? Or to the left, I should say. So negative 3.5 or negative 7 halves. So we can say directrix is x equals negative 7 halves. That's how you do it. Done. So for this one, it's almost in that nice, perfect standard form. The only thing I'm going to do is I'm going to pull a 4 out of that 24. So I'm going to say 4 times 6 times y plus 1, because now I can see that p-value will be that 6, okay? So let's start with the vertex. Oh, by the way, so the x is squared, and that's a positive p-value. So we know that this parabola is going up. I like to draw a rough sketch knowing that the focus is above it, right? It's inside, wraps around it, and my directrix is a nice horizontal line beneath it. Okay, so first we got the vertex opposite of these two values, negative 4 comma negative 1. Okay, the focus is as I mentioned, we're going above or up by this value, which is 6. So my focus is negative 4 comma negative 6 plus negative 1 plus 6 is 5, and then my directrix, okay, is this value down here, and we're going 6 below that vertex. So you minus 6 from that, and it's y equals negative 7. That's how you do it. Done. So for this one, to get this into standard form, I recognize that the y is being squared. So what I'm going to do is I'm going to say y squared. I'm going to group that negative 6y, and then we're going to move everything else to the other side. So we got equals negative 12x minus 21. Okay, now what I'm going to do is I'm going to do a little completing the square. Okay, so I'm going to take half of this, which is negative 3, square it, which is 9, and I'm going to add that to both sides like so. All right. Now on the left side, we're going to factor, because that is a nice perfect square, and it becomes y minus 3. So we got y minus 3 times y minus 3, or y minus 3 squared. And then over here, we got negative 12x minus, and then negative 21 plus 9 is negative 12. So negative 12x minus 12. Okay, now I'm going to factor out that negative 12, and we're going to have negative 12 times x plus 1. The last thing I'm going to do is I'm going to pull a 4 out of this. Okay, so we're going to have a 4 times what gives us negative 12? 4 times negative 3. Okay, so now we got it back in our nice format that we like so. And I know it's a y squared. So when it's y squared, it's going left to right. Negative p-value, it's going left like this, meaning we got our focus here, vertex here, and directrix is a nice vertical line like that. Okay, let's start with the vertex. So the vertex is going to be the opposite of these values. So for the x, it's negative 1. For the y, it's positive 3. When we talk about focus, we're going to use this value here, that negative 3. And you can see it's, 3 or negative 3, depending on how you want to look at it. But bottom line is we know we're going to the left by 3 to get the focus, since we know the orientation. So negative 1 minus 3, or plus negative 3, I should say, is negative 4 comma 3. And last but not least, the directrix goes the other direction by 3. And that is x equals, so again, the vertex is at negative 1. So we're adding 3 to that, and that gives us 2. And that is how you do it. Done. So for this one, we're going to start by kind of grouping these two together and maybe factoring out a GCF of 5. So we got 5 times x squared minus, and then 50 divided by 5 is 10x. And we're going to leave some room because we're going to eventually complete the square. And that equals, and then we're going to move everything else over. Positive 4y and negative 113. Okay, now we're going to complete the square, and we're going to do that by taking half of this, which is negative 5, and squaring it and adding it to both sides. So that's positive 25. Now, before we add 25 here, remember that's really 5 times 25, which is 125. So that's what we have to add here to balance it out. So on the left-hand side, we got 5 times, and then that's a perfect square. We're going to factor it as such. X minus 5 squared equals 4y, negative 113 plus 125 is positive 12. Then we're going to factor out the 4, and we got y plus 3 equals all of this, okay? And there is a 5 there, but I'm going to divide both sides by 5. Get rid of that 5 and bring it over here like a nice fraction. Last step to get our nice standard form, I'm going to extract the 4. I'm going to pull the 4 out, leaving a 1/5 in there, right? Dividing that by 4 is 1/5. Times y plus 3, and now we have our p-value. So since it's x squared and we have a positive p-value, I know that this is going to be going up, meaning if this is my vertex, here's my focus, and my directrix is a nice horizontal line beneath. Okay, now let's get everything. So first, let's get the vertex. So it's the opposite of negative 5, which is 5, opposite of that, which is negative 3. focus, what we're doing is we're going up by 1/5 from the vertex. So we're at 5. -3 plus 1/5 is -2 4/5, but as a improper fraction, -2 times 5 is 10 plus 4 is 14. So we got -14 over 5. And then the directrix, we're going down by that 1/5. So instead of -15/5, it'd be -16/5. And it's y equal to that because it's a horizontal line. Y equals -16/5. And that's how you do it. Done. So this one, we're going to start by keeping the x squared minus 4x on the left-hand side and moving this stuff over here, making it a -2y by subtracting it and adding 6 over here to the right side. Then what we're going to do is we're going to do a little completing the square by taking half of that and squaring it. So that's -2 squared is 4. So we're going to add that to both sides like so. And now what we're going to do is we're going to factor this on the left-hand side because it's a nice perfect square. That's what we did. We made a perfect square. And that is x minus 2 times x minus 2 when you factor it, which is x minus 2 squared, equals. This becomes 10, okay? And then I can factor out a -2. So we got -2 times y minus 5. Why is it minus 5? Because when -2 comes back in to multiply it, it goes back to 10, which is what we had originally. Last but not least, again, I'm going to pull a 4 out from this. So we'll pull out a 4 from the -2, basically dividing the -2 by 4, which leaves a nice -1/2. Now we know it's x squared and we know we got a negative p value. That means this is a parabola going down like so, putting a vertex here, a focus here, and a nice directrix up top like so. Okay, so let's start with the vertex. So the vertex is the opposite of these values in the parentheses, +2, +5. The focus is going down by that p value, or we could say, adding -1/2 to the y value of the vertex. So that becomes 2 and 4.5, or sorry, 4.5, or we could say as an improper 9/2. And then for the directrix, we're going 1/2 in the other direction. And that's going to be y is equal to, again, from 5 adding 1/2, 5.5 or 11/2. That's how you do it. Done. So for this one, we're going to start by keeping these y's on the left-hand side like so. And then I'm going to move the x over here. I'm going to add 4x. I'm going to minus 23. Then we got to complete the square. Okay, so first thing, I got to factor out a 3 over here. So it's y squared minus 2y, leave a little bit of room. And then we still got this. Then I'm going to complete the square. We're going to take half of this value, which is -1, square it, which is 1, and add that here. But we also must add it to this side, remembering that that's really a 3 times 1, which is 3. So we got to add 3 over here. And then now we can simplify a little bit. So we got 3 times, we can factor this because we made a nice perfect square trinomial. That's y minus 1 squared is equal to -23 plus 3 is -20. And then over here on the right-hand side, we're going to factor out that 4, and we got x, and then from that would be -5. And just so we can see it, we don't need this here because we got the 4, and that's kind of what we want, but there will be an invisible 1, or we can put a 1 in there. And that's just going to be so that we can see our p-value nice and clear. The other thing is the p-value is positive, and this is a y squared. That means this is opening to the right. That means our focus is going to be here inside, and my directrix is going to be back here as a vertical line. So now to get the vertex, it's going to be the opposite of what's in the parentheses. So 5 for the x, 1 for the y. For the focus, again, it's moving to the right by that p value, which is 1. So it's going to be 6, right? 5 plus 1 is 6, same y value. And then the directrix going 1 the other direction, which would be, and again, it's a vertical line, so it's x equals, and that would be 4. And that's how you do it. Done. So for this one, we're going to graph it, but before we do that, I'm going to get it into a nice standard form by multiplying both sides by 8, and that gives us y squared equals 8x. Another way to write that will be y squared equals 4 times 2x. And that's nice because that gives us our p-value. Okay, now let's talk about all these different components. First, we got the vertex. Since we have nothing like no y minus or x minus, we know the vertex is at the origin, which is 0, 0. Then I can find my, and by the way, this is y squared and it's a positive p-value. That means it's going to open to the right like that. So my focus, if it's opening to the right, my focus is going to be to the right of that vertex. So I know I'm going to add that positive 2 to this x value here, and it's going to be 2 comma 0. And then the directrix is going to go 2 in the other direction. But since it's opening like this, we know it's a vertical line. And so my directrix is x equals negative 2. Now let's plot it out. So there's my directrix right here. Here is my focus right there. And then we can graph the parabola approximately like this. And that's how you do it. Done. So for this one, we're going to start by multiplying both sides by 36 to get it in our nice standard form. So it's x squared equals 36y. And then again, I'm going to pull a 4 out, right? So it's really, 36 is really 4 times 9y. And that's nice because now I know my p-value is 9. I also know that since it's x squared and my p-value is positive, it's opening up like this, all right? So now let's get our vertex. Again, there's no x minus or y minus, so I know my vertex is that origin 0, 0. And then to get the focus, we take that p-value, and since I know it's opening up, the focus is going to be above that, and it's that 9 value that we're adding, so it's going to be 0, 9. And then my directrix is going the other direction down below 0. It would be at negative 9, so my directrix, again, and it's a horizontal line, right? It's y equals negative 9. So let's graph that. So there's my directrix. There's my vertex, and here is my focus. And this is going to look something like this and like that, and that's how you do it. Done. So for this one, we pretty much got it in an amazing format. The only thing I'm going to do is I'm going to pull the 4 out over here, and dividing that by 4, we get negative 1/3, and then x plus 2. Okay, that's just going to help me so we can see a nice clear p-value. Again, it's y squared and it's a negative p-value, so that means we're opening this way. Okay, now let's get all the critical points. So first, let's get the vertex. That's going to be at negative 2, opposite of that, and positive 2, opposite of that. Let's get the focus, and now since my p-value is negative 1/3, and I know it's opening to the left, I'm going to take that negative 1/3, add it to this x value, and we get negative 2 1/3, or negative 7/3, comma 2. And then my directrix, we'd be going the other direction, so we're going to add 1/3 to that, which would be negative 1 2/3. Again, it's a vertical line, so it's x equals negative 5/3. So our vertex is at negative 2, 2. Our directrix is right behind it. And then our focus is 1/3 to the left, little focus there. And then we kind of wrap it around like this, wrap it around like this. There's your graph. That's how you do it. Done. So for this one, we're pretty much in good shape. The only thing I'm going to do is I'm going to divide both sides by negative 6. 4 over negative 6 is negative 2/3. And then I'm going to do one more thing. I'm going to extract the 4 from this. So I got y plus 5 squared is equal to, and then we pull a 4 out. And that's like dividing this by 4, which would be, I think, negative 1/6, right? And so now I can see my p-value is negative 1/6. I'm actually going to change this graph. That'll make it easier to graph now. And then we got a vertex first. So vertex is at positive 4, negative 5, opposite of those two. And I know that my focus now, and by the way, this is y squared and it's a negative value, so it's opening to the left. So I know my focus is going to be to the left. So it's basically like adding that negative 1/6, which would be 3 5/6, which is the same as 23 over 6, comma negative 5. And then my directrix, which is going to be a nice vertical line. So x equals, and then x equals what? Well, I have to go the other direction, right? I have to go to the right. So 4 1/6, which is the same as 25 over 6. All right, let's draw these out. So here's approximately 4 1/6 for the directrix. My vertex is at 4, negative 5 right here. And then the focus is just to the left. Again, really small right there. And then we're going to wrap around like this, wrap around like this. There's your approximate graph. That's how you do it. Done. So for this one, before I start, we need to get it into our nice standard format. So I'm going to keep the x squared plus 8x on the left-hand side, and then we're going to move that negative 4y and we'll minus 20 as well to the right-hand side. And then we're going to complete the square. I'm going to do that by taking half of this, which is 4, and squaring it and adding it to both sides. So that's 16 and 16 over here. Okay, now we have on the left-hand side, we can factor that, and it's a nice perfect square. X plus 4 squared is equal to negative 20 plus 16 is negative 4. So then now what I'm going to do is I'm going to factor out a 4, well, really a negative 4, but I'm going to break it up into 4 and negative 1. And then inside we have y plus 1, right? Because if you redistribute negative 4, you get negative 4y minus 4. Okay. Now we can, and by the way, this is nice because we have our p-value at -1. So what is my vertex? Well, it's the opposite of these two, so -4, -1. My focus, again, this is an x squared with a negative p-value. It's opening down. So my focus is going to be down here, right? It's going to be in the inside. So we're going to go lower by that p-value, so -4, -2. Last but not least, for the directrix, we go up that same 1 value, so up by 1 is going to be y equals 0. All right, let's plot it out. There's my directrix. My vertex is at -4, -1 right here, and then the focus is right below that. Boom. And then we're going to wrap around like this and come around like this approximately, and that's how you do it. Done. So for this one, I'm going to group the y's together on the left-hand side. So we got y squared plus 10y equals, and then we're going to add 8x, and we're going to minus 9 on the right-hand side. Okay, now we're going to do a little completing the square. So I'm going to say y squared plus 10y, and then we're going to take half of this, which is 5, and square it, which is 25, and add that to both sides, like so. And then we have on the left-hand side that factors to y plus 5 squared. On the right-hand side, 8x minus 9 plus 25. That's 8x plus 16. Last but not least, we're going to factor out that 8, okay, y plus 5 squared equals 8. And by the way, when I take out the 8, I'm going to break it up into a 4 and a 2 because we're always trying to extract a 4 in the standard equation so we can easily see our p-value. And then if I'm dividing the 8x plus 16 by 8, I got an x plus 2 left inside. Okay. So now we can get all the pieces. We know that the vertex is the opposite of those two, which is -2, -5. I know that the focus is going to go, well, again, it's y squared, so it's either going left or right. Positive p-value means we're opening to the right. So that means the focus is going to be in here, and it's going to be that distance p to the right. So 2 to the right, -2 plus 2 is 0, comma -5. And then since it's going like that, the directrix is a vertical line, so the directrix is going 2 to the left, meaning x equals -4. Now, as we plot this out, there's x equals -4 as the directrix, and we got a vertex at -2, comma -5 right here, and then our focus right here at 0, -5. And then we approximately wrap around like this, like this. That's an approximate graph, but that's how you do it. Done. So for this one, we're going to start by getting it into standard form. So I'm going to get the y squared plus 2y over here, and then I'm going to move this over as 12x, and then minus 61, right? We're subtracting those from the left-hand side. Now we're going to complete the square by taking half of this and squaring it. That's 1 squared, which is 1, and we add it to both sides. And then we're going to rewrite this as, again, I can factor this because it's a perfect square trinomial. Y plus 1 squared is equal to 12x minus 60. Now I can factor out a 12 from the right-hand side, but I'm going to break it up into 4 times 3. Because again, that's 12, number 1. Number 2, I like to have a 4 out here so I can clearly see my p-value. And then if I factor out a 12 out of both of these, it's x minus 5. And then over here we have y plus 1 squared. Okay, it's a y squared and it's a positive p-value. That means we're opening to the right. Okay, and then now let's get my vertex first. So the vertex is the opposite of those two, which is 5, -1. And again, since it's opening this way, I know my vertex is going to be to the right. So I'm going to take my p-value and I'm going to add it to that vertex to get the foci. 3 plus 5 is 8, comma -1. And then to get the directrix, we go 3 in the other direction. And it's a vertical line. So it's x equals -3 plus 5 is 2. Okay, there's my directrix. Okay, let's plot this out. So there's my directrix. My focus is at 8, -1, and then my vertex is at 5, -1. And then we kind of wrap around like this and like that. And again, it's an approximate graph, but that's how you do it. Done. So for this one, we need to find the equation of the parabola, and it's telling us our vertex is 0, 0. The directrix is a horizontal line at y equals 4, and the focus is below that at 0, -4 down here. So I'm just making an approximate graph just to give you an idea. That means this vertex is right in the middle. It's going to bend around that focus, okay? So this immediately tells me that it's going to be an x squared situation, and we have x squared. And it's not, otherwise I'd say x minus something, y minus something, but the vertex is 0, 0, so it's x minus 0, so x squared is equal to, and what's my p-value? okay? My p-value is clearly 4 because I'm going 4 below to the focus, 4 above for the directrix. So normally it's 4 times p times y. Well, I know p is 4, so we can say 4 times 4, which is 16. But one more quick note, again, it's going down, so that is negativo, so we need negative 16y, so that's how you do it. Done. So for this one, we know the vertex is 2, 2. We know the directrix is x equals, okay? And it's minus rad 2. That means it's to the left, so it's over here. And then the focus is plus rad 2, which is over here, okay? So here's the focus, and roughly it's going to go like this. And again, going to the right, opening to the right, my p-value is going to be positive. Okay, so first of all, you know, if my vertex is 2, 2, I know we're starting off with, and again, it's opening to the right, so it's a y squared. So y minus that vertex value 2 squared is equal to x minus 2, like that. And then what do we have out front? Again, I know my p-value is positive, and it's going to be this distance, which I know is rad 2, and then it's going to be 4 times that. So we can have 4 times rad 2 right here, and that's how you do it. Done. So for this one, we got a vertex, and we've got a directrix that looks to be to the right of this vertex. So it's going to be over here, and it's a vertical line, and then the focus is to the left at 0, negative rad 3. So what I'm seeing is, as we move to the right, it looks like we're adding rad 2, right? Adding rad 2 even to get to the directrix to get that 2 rad 2. So that means my p-value is rad 2. We can say it's negative rad 2 if you'd like to indicate that it's opening to the right. Just remember that when it's opening to the left. Just remember when it's opening to the left or opening down, in the case of a up and down parabola, we know that we should have a negative, okay? So now we can start to piece this together. And again, it's going to be y squared, not x squared. So we have, here, let's do it down here so we have some room. Y minus this value of the vertex, so that would be a plus rad 3 squared, and then on the other side we're going to have x minus that value, x minus rad 2, like so. And then what we're going to have out here is 4 times that p-value, which we already said is negative rad 2. Or if you forget that it's negative, you could just be like, well, wait a minute, it's 4 rad 2, because I know the p is, you know, that's a distance of rad 2, but it's opening left, so we got to have a negative. And that's how you do it. Done. So for this one, we know we got a vertex of 0, 0, and we're opening up. So right off the bat, we're going to start with an x squared is equal to, and then again, we have 4p times y. Now, p is going to be positive, and what is the p-value? It's that distance from the vertex to the focus, which is 1/4. So plug in 1/4, and 1/4 times 4 is 1. So my final answer is x squared literally just equals y. That's how you do it. Done. So for this one, we're opening to the right, and we've also got a vertex here. So I know right off the bat, it's going to be, the y is going to be squared, and it's going to be y minus that value, the vertex, so y minus 2 squared is equal to, and then it's x minus that value, which would be x plus 2. And now over here, we have 4 times p. So the question is, what is p? And I know p is positive because, again, it's opening to the right. Well, p is this distance from negative 2 to negative 31 over 16. So these are crazy fractions, right? So negative 2, we could rewrite that with the common denominator. That's negative 32 over 16. And then to go to negative 31 over 16, what is that? It's adding 1/16. So p is positive 1/16. So we plug it in here. 1/16 times 4 is 1/4. So our final answer is y minus 2 squared equals 1/4 positive times x plus 2. That's how you do it. Done. So for this one, we know we're opening to the right, and we also know that we have a vertex at negative rad 2, rad 3. So it's going to be y squared. We're going to have a positive p-value. So let's start with y, and then it's minus that value of the vertex, the y value. Y minus rad 3 squared is equal to, and then we have x minus this value, so x plus rad 2 over here. And then we're multiplying this by 4 times p. So what is the p-value? How much are we adding to go from here to the focus, right? And it looks like we're literally adding rad 5. It's right there. So p is rad 5. So I can rewrite this as y minus rad 3 squared equals 4 rad 5. Positive makes sense because we're opening to the right, right? Times x plus rad 2, and that's how you do it. Done. So here what we're given, basically, when they say vertex and endpoints, we can just classify this as a vertex and 2 points on the parabola. So let's sketch that out. So we got a vertex of 0, 0, then we have -2, 4, and -2, -4. Okay, so we kind of already know that we're kind of coming around like this and coming around like this. And if we're trying to get our equation of this parabola, we already know that it's a y squared, right? Because it's going left, and we know our p-value is negative. And since the vertex is 0, 0, we know it's y squared equals 4p x. So now the question is, what is p? Well, one of the nice things I can do is plug in either of these coordinates, right? 4 for y, -2 for x. And we get 4 squared is 16 equals 4 times p times -2. This becomes -8p equals 16. Divide by -8p equals -2. Okay, so then I plug it back in here, and I got y squared equals 4 times -2, which is -8 x. That's how you do it. Done. So for this one, we're just going to graph out these points just so you can get an idea of what it looks like. Vertex at -3, -1, and then we got a point at 0, -7, and 0, 5, like so. So I already know since it's opening to the right, it's y squared, and we have a positive p-value. Okay, so it's going to be y minus that value, which is y minus -1 is y plus 1 squared equals 4p times x plus 3. And the question is, what's our p-value? Well, guess what? We can do a little plug and chug with either of these coordinates. Let's plug in 0 for x and 5 for y. 5 plus 1 is 6. Squared is 36 equals 4p times 0 plus 3, which is 3. That's 12p equals 36. Divide by 12, p equals 3. Now we can rewrite this as y plus 1 squared equals 4 times 3, which is 12 times x plus 3. That's how you do it. Done. A mirror of an automobile headlight has a parabolic cross-section with the light bulb at the focus. On a schematic, the equation of the parabola is given as follows. At what coordinates should you place the light bulb? What are they really asking here? Where is the focus? Okay, so I'm going to rewrite this as x squared equals, and I'm going to extract the 4 out, but really there's just a 1 left. But that's helpful because that tells me my p-value. Okay, so my p-value is 1, and this is a parabola that's opening up, right, with a vertex at 0, 0. So the focus is going to be above that by exactly a distance of 1, which means the focus is at 0, 1. That's where you place the light bulb. That's how you do it. Done. A satellite dish is shaped like a paraboloid of revolution. This means that it can be formed by rotating a parabola around its axis of symmetry. The receiver is to be located at the focus. If the dish is 12 feet across at its opening and 4 feet deep at its center, where should the receiver be placed? Okay, just so you can get a visual, we're going to assume the vertex as the origin. Doesn't really matter. And then it says the dish is 12 feet across at its opening and 4 feet deep at its center. So 4 feet up, we're going to go 6 right and 6 left. And this should be roughly what it would look like, okay? So the question is, where is the focus? I know it's going to be somewhere up here, but I don't know exactly where. But let's see if we can kind of come up with a nice little equation. So my vertex is 0, 0, and it's opening up. Well, that means it's an x squared situation. So we get x squared equals 4p times y. Okay, so now the question is, what is my p-value? And we're going to use that to find the focus. Well, if I've got a coordinate here and here, that means I've got, and I'll just choose one of these, I got a coordinate at 6, 4. Well, guess what? Plug in 6 for x, plug in 4 for y, and I can solve for p. 36 equals 4 times p, and then y is 4. And that's 36 equals 16p. Divide both sides by 16. Boom, boom. And we've got p equals, let's see, divide top and bottom by 4. That is 9/4. Okay, so my p-value is 9/4, which means we would go up by 9/4, which is 2.25 in decimal format. So we would say 2.25 feet above that vertex. And that is how you do it. Done. A reflector in a searchlight is shaped like a paraboloid. A light source is located 1 foot from the base along the axis of symmetry. It's probably the focus, I'm just guessing. If the opening of the searchlight is 3 feet across, find the depth. So just to get an approximate graph, right, we could say here is the base or the vertex, and we could say it's 3 feet across, 1 foot up. So I can go 1.5 to the left, 1.5 to the right, like so. So again, this is an approximate graph. And what I'm guessing is we're assuming, I think this is what we have to do. We have to assume that this is the focus, 1 foot up, okay? And so that tells me, again, my vertex is 0, 0. It's opening up. So we can say x squared equals 4py. And now if my focus is literally exactly 1 above, what that means is p is 1. So we can say x squared equals 4y. Okay, then it's saying the opening is 3 feet across. So what we're trying to do is we're trying to find the y value at that point. And 3 feet across, just like we said, it's 1.5 out to the left and to the right. So positive 1.5 or negative 1.5 is what we should be able to plug in for x. So let's do that. Now let's plug in 1.5. And what we're solving for is y, because that gives us the depth, okay? 1.5 squared is 2.25, and that equals 4y. Divide both sides by 4, boom, boom. And when we divide it out in decimal format, we get 0.5625. So 0.5625 feet, that's the answer, done. An arch is in the shape of a parabola that has a span of 100 feet and a maximum height of 20 feet. Find the equation of the parabola and determine the height of the arch 40 feet from the center. All right, just so we can visualize it, a span of 100, so we can say from negative 50 to 50. Again, this is arbitrary, okay? And then a maximum height of 20 feet. This is just to give us a rough graph, a rough sketch. Find the equation of the parabola and determine the height of the arch 40 feet from the center. So we're going to kind of say like, like this. And then to find the height 40 feet from the center, we go across 40 and we find that corresponding y value right there when x equals 40. Okay, so I see that it's opening down, so I know it's got to be an x squared function, and our vertex is right here, which is 0, 20. Okay, so that means it's going to be x squared is equal to y minus 20 and then times 4p. Again, p is going to be negative, but we're going to figure out what that is in a second. Okay, now to figure out what p is, I know I have a coordinate here at negative 50, 0. So we're going to plug and chug in here and 0 in here. And then we get negative 50 squared, which is 2500, is equal to, and then we get 4 times negative 20 is negative 80 times p, and we divide both sides by negative 80, and we get a p-value of negative 31.25. So now as I take this and plug it back in here, 4 times that gives us negative 125. So our final answer is x squared equals negative 125 times y minus 20. The last part is now we have to plug in 40 for x and solve for y. So 40 squared is, let's put it up here, 1600 equals negative 125 times y minus 20. We're going to divide both sides by negative 125, and we get negative 12.8, and that equals y minus 20. Last step, we add 20 to both sides like so, and we get positive 7.2. So we will say it has a height of 7.2 feet, 40 away from the center. That's how you do it. Done. An object is projected so as to follow a parabolic path given by this equation, where x is the horizontal distance traveled in feet and y is the height. Determine the maximum height. Okay, what are we talking about here when we're talking about maximum height? We're talking about the vertex, okay? Now, you know, I could reformat this and find the vertex and all that, but I'm going to do a throwback to a really nice equation to find the vertex of a parabola when it's in this nice like format here, okay, where it's y equals ax squared plus bx plus c. C is 0. The vertex occurs at negative b over 2a, and then the y value, that's going to be the height. That's going to be when you plug this in for y, okay? So what is negative b over 2a? Well, a is negative 1, b is 96. So negative b is negative 96 over 2a, that's negative 2, that equals positive 48. Okay, now to find the height, we plug and chug this in here for the x values. Let's do that in Desmos. So there, as we plug it in, we get 2,304. So the answer is 2,304 feet. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.